In this video, we're going to look at elimination reactions that can produce multiple products, so different alkenes depending on which hydrogen we remove. So we're going to start by looking at a dehydrohalogenation example, and we're going to look at the dehydrohalogenation of 2-bromohexane. So I'm going to start by drawing the structural diagram of 2-bromohexane. So we have a 6-carbon chain and hydrogens everywhere, except for on that second carbon where we have a bromine. So we're going to react this with a strong base, as we do for dehydrohalogenation reactions. And we're going to have to look at what we can remove. So our bromine is definitely going to be coming off of this molecule in our dehydrohalogenation. And so this carbon attached to the bromine is going to be affected. And we have to look at the 2 carbons on either side. So the 2 carbons adjacent to that bromine. And so on this first carbon, we could remove any of these hydrogens. And on the third carbon, we could remove any of these hydrogens. Now, if we were to remove hydrogens off of carbon 1, we will get a different product than if we remove the hydrogens off of carbon 3. So if we remove the hydrogens off of carbon 1, our double bond will be between carbon 1 and 2. And we'll be left with 2 hydrogens on carbon 1, 1 on carbon 2, and we won't change anything about carbons 3 through 6. So that is our product if we remove a hydrogen off of C1. That product is called hex 1-ene. If we remove that carbon instead off of C3, our double bond will be between carbons 2 and 3 instead. And so carbon 1 will be untouched, 3 carbons on there. We'll still have our 1 on carbon 2, 1 on carbon 3, and 4, 5, and 6 will be untouched. So that's the product if we remove our hydrogen from carbon 3. This product is hex 2-ene. You will not need to know the proportions of the products or which one is more likely to form. You just need to know that it is possible to form both. In this example, we're going to look at the dehydration of 3-ethyl cyclohexanol, so a dehydration reaction with multiple products. This time I'm going to draw the line diagram instead of the structural diagram. So it's sometimes a little trickier to see with a line diagram, but we'll figure it out. So cyclohexanol, the OH group has to be on carbon 1, and our ethyl is on carbon 3. So even though it's not indicated here, that OH is on C1, so it gets priority. Okay, so we're going to start by highlighting the carbon to which our OH group is attached. And we're going to look at the 2 carbons adjacent to that OH. So we have our red carbon and we have our yellow carbon. So our yellow carbon has 2 hydrogens. I'm just going to draw them as little dots. And our red carbon also has 2 hydrogens. So when we place this molecule in the presence of a strong acid, if we were to remove a hydrogen from that red carbon, so I'll do that first, our double bond will go here, and our ethyl group will still be there. And we have water as our byproduct. In this case, this compound, this is going to be carbon 1 and 2. So 3 and 4. So our compound will be 4-ethyl cyclohexane. If we were to remove the hydrogen from the yellow carbon, our double bond will go here, and our ethyl group will be there. And so we'll have 1, 2, 3, the same numbering as before. So this product is 3-ethyl cyclohexane. Again, you don't need to know the proportions of the products or which is more likely. You just need to know that both are possible to form.